Okay. How do you do, everyone? Welcome. So today is week 4, day 4, which is nice. It's been a little while since I've done. It is week 4, day 4, right? Have I prepared for the wrong lecture? Oh no. Yeah. So it's been a little while since I've lectured for y'all, right? What was the last one I even did for you? Have I done any for you? I've done like 2, right? It's the Mongo. It was like the or not. Yeah, it was the Mongo one. There you go. Week 3, day 4. So it's been a whole week. Have you missed me? No? That's what I like to hear. All right, thanks, Joel. I didn't ask you, Joel. Thanks.
Yours doesn't matter.
Yeah. So, today we're not doing Mongo, but we're doing stuff that's kind of similar to some stuff that we had to deal with when we were using Mongo, right? Okay, so we're going to start up today kind of slowly, and then it's going to get faster and faster and faster, and then it's going to slow down a little bit just to the end. There's a good pace to this lecture. So let me start off by making a new file. This one's called notes.md. There you go. First of all, so hello Calgary. Please ask questions and I'll answer them. I've got the good old Slack popped open. Anyways, does anybody know what today's lecture is even about? No? All right. So it's about week 4, day 4. Cool. Cool. And the particular thing that we're looking at is errors and promises. All right. This is a lecture about my life. I've made a lot of mistakes, and I've made a lot of promises. So error number 1, go to university. No. Error number 1, yeah. Well, let's start with errors. So errors, I didn't invest in Bitcoin. That one was a pretty big error. Error number 2, I bought an Xbox 360 way too late, right? People were really getting into PC gaming, and I switched over from PC gaming into an Xbox 360 way too late, really bad. Another error, I bought Skyrim. That's kind of like a sub-error, bought Skyrim. Probably around 400 to 600 hours lost. Nothing to show for it. Right, so I've made some errors, and I've made some promises. All right, what promises have I made? Hi, Davey. I promised myself that I would finish undergrad in 4 years. 4 years? Rounding about 6 right now, so that's good. I promised myself I would, yeah, I would reach these keys. Yeah, so some of these I've actually, hit. So I reached these keys. Get into fantastic shape. So, if I go through the errors, this is some stuff that happened and I've kind of had to deal with it, right? I didn't invest in Bitcoin. How did I deal with it? Well, I cried a bit, right? I bought an Xbox 360 way too late. How did I deal with that? Well, let's actually unnest that one. What's that? Yeah, well, but bought Skyrim, that was a mistake, but I dealt with it by just having fun and not worrying about it too much. And buying an Xbox 360 way too late, well, I just had to make new online friends, right? I'm just trying to show you that we have errors and we deal with them, right? We make mistakes in life and we kind of deal with them, right? Here's another error. Opened up too fast to someone. I'm not going to go into that. And here's some promises. I said I would finish undergrad in 4 years. I didn't, but it's okay, right? I deal with it eventually, right? So just about now, I'm dealing with finishing undergrad. I promised myself that I would reach these keys. And did I reach the keys? Kinda, right? And then I move on. To reaching other keys. All right. And then I made a promise that I would get into fantastic shape, and I did, right? Look at these traps. But I can always do better. You're forever small, so yeah, so keep going. Okay, now I'm not just saying this stuff to be funny, right? I'm trying to set up the pattern of the things that we're going to be dealing with today. Sometimes mistakes happen, right? We deal with it. And sometimes we promise something that takes a little while, right? It's going to take a little while for us to get there. And I might want to, like, I'm finishing undergrad, but I'm also reaching the kids, right? And I'm also getting into fantastic shape, and I can do all that stuff at the same time. And they might finish at different points, right? Okay. So are we seeing how these two things are kind of related? Because like at some point, I might not actually reach the kids, right? And that's like an error. And maybe I'll try again, right? Or maybe I'll move on to a different, I shouldn't have picked that. That's such a weird kind of example. But you get what I'm trying to get at without code, right? Okay. Now we're going to take these kind of dumb ideas and integrate them into our JavaScript workflow or our programming workflow. Okay. So our goals for today, let me highlight these out. Our goals for today, number one, we're going to be dealing with something called a try-catch, and then there's a finally, and just general control flow with errors in JavaScript. Okay, that's the first thing. We're like, what does that mean? I have no idea. We're going to discover that together. The next thing I'm going to look at is how do we deal with these errors, whatever they are, in async code. And I saw like a hush fall over the crowd as I said the word async. Yeah, because it's scary, right? Asynchronous stuff, what does it mean? Ooh, ooh. Yeah, so we're going to deal with errors in synchronous code, and then we're going to deal with errors in asynchronous code. And then what are we going to do? We're going to look at promises and their benefits. Like, why is it good to make a promise to someone and say, hey, I'll do it? Why is that a good thing, right? Except in code. Except in JavaScript. Okay, so these are our goals for today. At the end of the lecture, I think I'll come back and we'll see if I've actually managed to hit all of them. Fingers crossed. So, first of all, I'd like to plug a book. So, this is a book. I'll put a link to it in here because I know it's really small for Calgary. So this is a book, actually small for you too, by an author called Kyle Simpson. And it's part of a series called You Don't Know JS. Now, what does that mean? You don't know JS. What does that stand for? Yeah, it stands for JavaScript. It could also stand for something much ruder. But it'll stand for JavaScript. You might want to do some supplemental reading to get really good at some of the features of JavaScript if you intend to be a JavaScript developer, right? Like, we're learning the surface level of a language, but look, you can go deep if you want to, right? You don't need to, but you can if you want to. Anyways, part of the reason for why I bring this up is you notice these post-it notes. Some of the examples that I'm going to use today are pulled out of the post-it notes, right? Not all of them. Actually, very few of them, but they're from here. I just like citing my sources because I don't want to get caught on plagiarism. So let's start with this example up here. I didn't invest in Bitcoin, and then I had to just kind of like cry a bit and move on with my life, right? Now, if I was to write this out as some JavaScripty like code, let's get this wrong. So it's two backticks, eh? Or is it? Is it 3? Man, markdown. 3. Okay. So if I was to write this out, I'm like, let's see. Let invest in Bitcoin equals false, because I didn't invest in Bitcoin. And then it might be something like, cash out Bitcoin. All right. And this is some let dollar amount equals cash out Bitcoin. Now, I might have this cash out Bitcoin thing, right? Like a function, cash out Bitcoin. This is going to be pseudocode, okay? Like, don't take this code very seriously. And in here, maybe it's trying to cash out. Okay, but as part of the logic, right? It needs me to have invested in Bitcoin. Right? It needs me to have invested in Bitcoin, but did I invest in Bitcoin? No, right? So something's going to go wrong, right? When I call this, something's going to go wrong, right? Now, let's think about like mature adults, right? Like real people. If I ask you to do something and you can't do it, like it just doesn't work, do you like just cry about it and then never tell me that it ended up not working, right? Do you actually explode into smithereens, just into the ether, and does like the whole world stop existing? That's B. Or C, do you come and tell me about it? Right? You come to me and say, hey Nima, it didn't work, can we figure something out? Right? Which of options A, B, or C do we pick? C, right? We especially don't explode into smithereens and have the entire world stop existing, right? So similarly, in a computer program, right, if something doesn't work out perfectly, we might not want the computer program to just go, and then die, right? We might want it to handle that gracefully, right? So at the moment, right, this could cause a crash, right? It could cause a crash. So that's not good. It's not very good. I might get some kind of error. I shouldn't have used the word error. I might get some kind of bad message in my console that says, hey, you tried to do something illegal, right? And we couldn't deal with it, right? And that is obviously not something that I do want to do. So instead, I might say, hey, okay, I recognize that, like, you might not work out. I recognize that this relationship might not work. Right? I'm changing my example from Bitcoin to working relationship. All right. Continue with relationship. I'm pulling stuff out of my life. I recognize this might not work, right? So what we'll do is we'll try, right? We're just gonna try. We're gonna try to make it work. And if it doesn't work, then it's fine, right? We just, yeah. So I don't know why I'm putting dollar amount equals to relationship, because yeah, sure. Sure, yeah, I am a gold digger, I guess, yeah. So if that doesn't work, then we, move on with your life, whatever, right? Okay. Are we getting the weird syntax here? We're gonna try it, right? And if it doesn't work, then we're gonna move on. We're gonna catch some like error, right? We're gonna catch the fact that it didn't work. It didn't work. We're gonna catch that, and we're just gonna move on with our life, right? Maybe I'm gonna go to therapy with and tell them that why didn't it work or whatever. Like I'll be able to catch that and continue with the knowledge of this not having worked. Okay, so yes.
Out of continuing with the relationship, with throwing it didn't work, or where does it didn't work come from?
Exactly.
When do you decide it didn't work?
When do we decide it didn't work? So at some point within here, right? At some point within here, it didn't work. It threw an error. That's the language I'm going to use. I'm going to say it threw an error, right? And something outside, right? A catch statement is going to catch that error and handle it, right? We're going to call this throwing and handling, right? Throw and handle. I always think of like a baseball kind of situation, and then you throw it and somebody gets it and they're like, I handled it. I don't know how much more physical I can get with that example. Like the code inside of here is going to, what's the word? It's going to throw it, and what's the code over here going to do? Catch it, okay, and handle it. Yeah, it's going to catch it and then it's going to handle it. Now, I am not using the word throw in here yet. I'm not generating my own errors. I'm just telling you that maybe this thing does not work and this thing over here catches that error. But we can we can specifically kind of throw our own errors. Say I had this function in here, I'm really regretting picking this example now. Continue. Then in here, say it doesn't work, we would use the keyword throw. Throw new and then error with the error message in here. Right? Didn't work because you can't parallel park very well. This isn't a real example. I don't know. I don't know what you're talking about. So throws a new error, and then this error is what can get caught over here. Right? Are we seeing how this works? Are we seeing the pattern? And I know I haven't run this code yet. I just want you to see it at a high level, and then we could run it. Let me just do that. Yeah, I'm leaving out this Boolean because I'm not actually using it inside of here, but I just wanted to. Oh, we lost you. Did they lose us? Still streaming. Wait, did you lose me like conceptually, or did you lose me streaming wise? And we're gonna have to wait like 20 seconds for the answer.
Years ago.
Oh, okay. All right, that's good to hear then. All right, so I was just gonna hop in here and hop into Node and just run the code. So let me just fire up some Node. Oh, right. So, whoops. I'm trying to run this therapy function that doesn't exist. Let me try that one more time. Doot, doot. So I'm just going to console log instead of that. Hey, what do we see here? Error. You can't parallel park very well. Right? So I tried running all that code that we had. Right? I just replaced the thing with a console log so we see what the error actually is. Right? And it's, hey, you can't parallel park very well. Right? I got an error thing that I can do stuff with. Now, I might want to, I don't like working inside of Node very much. Whoops, not like that. I don't like working inside of Node very much, so I usually hop into the console up in here. Just because it lets me like expand objects nicely. Right, so that's my error. And in a bit, like I think we'll pop into the error and look at more things, but I just want you to show you, I want you to see that what we get is a stack trace. We don't just get the message, but we get where did the error kind of come from as well, right? So this is where I would put code to handle that, right? If I didn't invest in Bitcoin, I would console log, hey, you're trying to cash out, but you haven't invested in Bitcoin yet. If I was trying to log into a website maybe, right, and my user does not exist, be like, hey, you're trying to log in, but you don't have a user, right? Opposite. If I'm trying to log out, but I'm not actually logged in, it might throw an error saying, hey, you're trying to log out, you're not actually logged in, right? I don't want my program to die on me, right? I just want it to tell me that something is going wrong. Now, the thing about this is it can be a little weird because what we're doing is we're interrupting the flow, right? We're interrupting the control flow of the code. And when I use the word control flow, I'll just go control flow. I'm talking about the order in which code is executed. And I point this out just because this thing kind of looks like an if-else situation, right? Like it kind of looks like this, just by structure. Ignore the, I don't know, just because of the curly braces and the words, like to me it kind of looks like that. And when I look at an if-else, I know that only one of these is going to run, right? But when we're talking about a try catch, this is going to run until it doesn't, right? It's going to run until it doesn't, and then it'll go run this, right? So say instead of just continuing with my relationship, it was also a Bitcoin situation. So I'm like, oh, invest in Bitcoin, attempt a 4-plate squat, right? Like one of these things is gonna fail, right? One of them might, or it was what, cash out Bitcoin. Okay. One of these things is going to fail. I don't know which one, but one of them might, right? I might fail right here, right? And if I fail right here, then my program is going to jump from here into the catch, right? If I fail at cash out Bitcoin, that means I've already executed this, but I fail right here and I jump over here, right? So I'm trying to say if I fail at cash out Bitcoin, attempt 4-plate squat was never going to run, right? It'll jump straight to here, right? That's why we have to be careful about how we write this stuff. Like the code in here might run, right? It'll run until it doesn't, and then it'll hop into the catch. What do we define as a fail?
Like for a function, you're saying like this cache of Bitcoin fails to run.
Mm-hmm.
Is that actually when you put in a value and then it errors out? Or?
So the question for Calgary is, what do I mean when I say that cash out Bitcoin might not run? Or what do I mean when I say it fails, right? Any exceptional situation, right? I'll use the word exceptional, right? Exceptional situations cause things to fail, right? Anything that isn't what we intend to happen, right? So say I'm trying to read a file, right? Say I'm trying to read a file. Reading a file might not work if I'm trying to read a file that isn't there, right? If I have some, if I have let file equal read file hello world.js, okay, and then maybe I want to console.log that file. This is pseudocode. Like I don't think there's a read file function that looks like this, but assume that this is what I was doing, right? I want to console log the file. Now, if the file does not actually exist, like if I look inside my thing and I don't have a hello world.js in here, right? I don't want to just move on with my life trying to console log out an undefined, right? Because that's confusing, right? That's just, as a developer, I want to know that maybe I typed this thing wrong, right? Like maybe I typed in, maybe there is a hello world, but I typed in hello world without an O. I would, as a developer, like to know that I made a mistake, right? So it's bad for me if console log, then console logs undefined. I would rather have this tell me, hey, you tried to access a file that isn't there, right? So that's a situation where inside of the read file function, right? Inside of the read file function, the people who made the read file function would have gone throw new error file does not exist, right? They would have written something like this on some situation, like if file exists, if file does not exist, then throw that new error. Like this code here would have existed inside of the read file function, right? In the same way that for me, continue with relationship, in here there's a throw new error, right? You see what I mean? Does that kind of answer your question for when you would want things to fail? Right? There we go. Cool. So I might not want to console log out a value that didn't come out right in the first place. Yeah, and what we call these are exceptions, right? Or exceptional situations. So you see the word error and exception kind of used interchangeably, right? I encourage you to do some readings on the differences, but that's out of the scope for us right now. Right. Cool. But yeah, the order in which the code is executed might be disrupted by like exceptions or errors popping up. Okay. And we have to deal with that. We have to deal with that. So sure, if I'm writing synchronous code, if I'm writing synchronous code that says, hey, first try continuing with the relationship. If that is fine, then go ahead and cash out your Bitcoin. And if that is fine, then go ahead and attempt a 4-plate squat, right? If I say that these things are synchronous, then my try catch, totally fine, right? Try catch, this thing works absolutely fine with synchronous stuff, and like we're golden, we're good. But the thing is, what if these things are asynchronous, right? If this, like, let's do a quick kind of look at asynchronous code, just to refresh. I know you've done async before, but if I have this let file and console log again, right? Except here, let's say that this was read file synchronously, like this is a synchronous file read. So this line of code doesn't get executed until this line of code is done, right? Let's say that this is read file async, right? So this thing is trying to read a file asynchronously, right? And I've spelled hello world correctly. Maybe I do have a file in here called hello world.js, really just to round out the example. Like this is not going to throw some kind of error, right? But if I try to console log the file before the file is completely read in, what do I get? What's that? I really need you to say it. There we go, thanks, yeah. It's like I need the pat on the back so I can keep going. It's like a baton pass situation. So if we try to console log the thing before we actually finish the process, then we get undefined out. So how did we deal with this? I mean, you can say it. There we go, yeah. What's that? Exactly, so we can put it inside of a callback, and we're comfortable with arrow functions, right? Okay, so we put it inside of the callback, and I say, hey, don't console log the file until you're ready, right? You wait, and then when you're ready, go ahead and you can console log the file. And this is fine. This is totally cool, except for the fact that it might not work. Like, what if I'm trying to read a file that doesn't exist again, right? I'm still trying to console log. Snap. Okay, well, what if I throw a big old try catch around this? Okay, so I throw a big old try catch around the try here. Here we go. All right, and catch, just console log, whatever the error is. Now, this might at first glance look okay, but once we've run past this line and this read file async situation has started, right, my code continues. And as far as it's concerned, no error has been run into yet, right? Because it's like, okay, whatever, I'm reading a file asynchronously. Maybe this is going to take 10 minutes to read this file. I'm not going to wait inside of this try-catch situation. I'm going to move on with my life, right? So maybe the code moves on and it's, yada, yada, doing other stuff. And then eventually, when this read file async calls the callback on a hello world that doesn't exist, right? Or like it tries to go for it, it just runs into an error or whatever, that error is not caught by the catch situation because we've already left it, right? We're already gone. So we need to come up with a better way of dealing with errors that actually works with asynchronous code. Because this, at the moment, is not going to let us deal with asynchronous code. Yeah. Catch? No, catch is there just in case. Yeah, catch is there just in case. Like if you don't run into an error, like say up here for my for this one here, say I didn't run into an error, it would never print out the error because I just didn't throw an error. Yeah, there's no error to handle if you don't throw one. Actually, one of the things that I didn't mention is that there's this thing called finally, right? Finally, this is, bless you. I was waiting for the last one so I just don't want to rack up the blessings because you get too powerful then. Yeah, so I might go try, catch, and then what's your intuition on what finally might do? What's that? Exactly. So finally is going to run regardless of whether you have an error or not. Right. So there's this finally that I just failed to mention. But yeah, catch is only going to run if you actually run into an error. Right? So we have to figure out a better kind of pattern for dealing with errors than try and catch when we're talking about asynchronous stuff. Right? So what we might do is kind of really really give in to that like callback style of doing things, right? Really buy into the convention of we're passing in a callback for stuff to happen after you've read the file, right? And the way that I might do that is with error first callbacks. Okay? So I'm going to use these things called error first callbacks, and what these are I'm going to say read the file asynchronously, and in the callback that I pass you, I'm going to pass two things. Error and then a file. You know, you could write out the word error or whatever. Like, the error is going to be the first parameter of the callback, and file or the output or whatever I'm expecting is going to be the second parameter of the callback. Right? And this is just a convention. In Node, right, for Node-style callbacks, people have agreed that since we don't know how many parameters there's going to be to the callback, let's make sure that the error is the very first one. Okay? We'll make sure that the error is the very first one, so when you're designing one of your callback functions, you'll say, whoa, okay. We'll say our callback takes an error in a file. Let's check to see if there's an error. Right? If there's an error, handle it. Right? Else, console log the file. Right? So this is going to be, instead of necessarily like an error object being thrown, right? We might have a message being passed into the callback. And this is on the person who defines read file async. This isn't necessarily on us as developers, right? We'll have to look at the documentation and see that, hey, read file async expects a callback that first takes an error and second takes the file, right? Now, I'm saying this, but I want to show you examples of where this happens. So we looked at Mongo, the Mongo driver the other day, like a week ago. If I was to look into the, let me just look into the reference over here. There we go, right off the bat. Mongo client connect. Is connect going to take a while? Yeah, it might take a little while. So here's the URL that we're connecting to, evidently, and then here's the callback for what to do after you've connected. And notice the callback goes error and then client, right? Error first. Okay, let's do another one. Let's look at connects. You haven't used connects yet so far, have you? You have? Cool. Right, so connects.js. Right, now connects, if I remember correctly, takes promises as well, which we're doing in the second half of the lecture. But I just want to look at man. Oh, there we go. Whew. Function, error, and then the object. Right? Right. Error, and then the object. This is a convention. Like, we have, as developers, decided that this is how we're going to do things. Right? Error, first, callback. Right? So I recommend reading into error, first, callbacks. Just find an article that kind of makes sense and really just go through it. And as you design your own asynchronous functions, right, or as you design your own functions that might throw errors that need callbacks passed in, design them with this in mind, that error first, callbacks, right? It's not the only way to do things, right? It's not the only way to do things, but it's the convention that I think is most widely used, right? I say it's not the only way to do things because we might also do things with these things called success-fail callbacks, So success, fail, callbacks. Right? And in a second, I'll let you kind of ask questions about this stuff, but we might, instead of having only one callback being passed in that handles an error, right? We might define two callbacks. Here is a callback for success, and here is a callback for a failure. Something went wrong, and then I would take this and move it up. Right, so see now, instead of having to do the error handling inside of one callback, right, I could do the error handling in a second callback, right? This is called a success fail callback situation, right? So honestly, pretty much the same idea as this, except whoever makes the read file async function, right, they would either call success or they would call fail in this situation, right? Whereas here the read file async people, what they're doing is they're calling your callback, right? And if there's an error, then they'll pass in there was an error, right? And that's going to go into the error section. And if there isn't an error, then what they would do is null, and here's your file, right? And I know you've seen this before, calling a callback on null. Have you seen this before, right? That's what you're doing. You're saying the error is null. There's no error, right? And on the other hand, the way the callback's written is it's handling that null by just not doing anything with it, right? Does that make sense, right? I think it's pretty cool, right? And just as an example of somewhere where you'll see success fail is Ajax with jQuery. So sometimes with these, see, you might pass in a success function. There you go. So disregard the way that this is written right now, but just see the fact that there's one function that has the word success inside of it, and there's another function that has the word like fail and error, right? Just disregard the fact that there's a dot in front of this. Imagine that this was a parameter being passed in, right? Okay. But there are situations where we'll see success, fail callbacks. Oh. And I'll link this into, there you go, see, success, and here they called it error, but you could call it fail. And this is on Ajax. Right. Just right here, are there any questions? Right? This is making some good sense, right? So we can see how if I was to go back to my original kind of like human life examples, these things, I have something that I'm trying and then some way of handling that, right? Something that I'm trying and some way of handling that, something that I'm trying and some way of handling that, right? I think I would suggest maybe coming up with these kinds of examples and writing them in code for yourself, right? Just to really kind of solidify this, right? It is 9:48, so what we're gonna do now is right. Yeah, this is my little screensaver. I have hot corners on because I like seeing the screensaver. Yeah, it's pretty cool, right? Got my little toasters, my little breads. Oh, sick! You can zoom in during the screensaver. That's awesome, dude. The more you know. Yeah, it would look pretty cool. Cool. So what we'll do now is I think we're gonna call it a break right here. We're gonna see each other in like 10 to 15 minutes, right? And then we'll continue. Alrighty. Just gonna wait up for the thing on stream now. Woo! All right, we're in. Welcome back, everyone. So in the second half, we're gonna deal with the second half of my problems here. So we talked about errors, right? There's a really great question about errors that we're gonna address before we move on to the second part of the lecture, which is promises. So the question is, well, it was about the try-catch and trying to do try-catch stuff with asynchronous stuff. So I whipped up this little demo. Here is a function called doAsync, right? It console logs a bunch of things, but the important part is that it sets a timeout, right? So this function takes at least 2 seconds to run, sets a timeout, and at the end of that timeout, it'll console log, hey, I did async, and then it'll throw an error, right? It's going to throw an error. And then over here I have try, and I'm doing async inside of that try. So inside of here, I will get an error. Right? I will get an error from here because that's what this thing does. Any confusion about this so far? We all get it? Cool. And then I've written catch whatever error pops up from within this try. Catch it and don't even display the error. Just console log the words hello world. So if everything works out fine, right, I should never see an error like a trace pop up, right? Like a stack trace, I shouldn't see that. I should just see the words, let's see, it should go outside of try catch, then about to do async, console log. Like I shouldn't see whoomp, there it is anywhere, right? And if I was to run this right now as node try catch async, it takes 2 seconds, and then it throws the error, and the error doesn't get caught by that catch, right? You see, so it's weird because if I'm looking at this, I would think that catch error will catch that thing and display console log, like hello world. I don't even see the words hello world on here, right? Because I can't do asynchronous stuff within a try catch, right, and expect that to work properly, right? So this is why we have to use error first callbacks when we're trying to handle errors in asynchronous code, right? So I encourage you to play around with this demo, which I'll put in, in the little GitHub with all that stuff. So do async. Any questions about this? Cool. Okay. So what we're gonna move on to is promises, right? Promises. And I have a couple things that I want to talk about promise-wise. First of all, I mean, this will be in the notes, but please always go look at the documentation, right? I might say stuff that just isn't correct, right? Like maybe I just made a mistake. Verify that stuff with the documentation. Sometimes I just don't have time to go deep enough into the things, right? Go deeper with the documentation. Okay? So I always link the documentation at the beginning of my notes. So these are just the notes that I used the last time I did this. So we did a try catch. We have to talk about error first callbacks and success fail callbacks. But there's some issues with callbacks. Here's a little demo. Say that, okay, is anybody familiar with a bop it? Yeah, bop it, pull it, twist it, yeah. Right, so for those who aren't, I don't know where you grew up. We didn't have bop-its in Italy. Well, I was in Italy until I was like 7, and then I moved here. So, I mean, I'm just like, yeah. I mean, I knew about bop-its as a kid, but this is the idea. This isn't a cool '90s commercial. Get out of here. Bop-it commercial in 1998. Yes. Yeah. There's gonna be no audio. So what? It's like twist it. Yeah, so that's the bop it. The 90s were such a special time. I just need to see. I'm sorry. This face. There's nothing that gives me. There's nothing that gives me that. Right? Bop it. Oh my God. Yeah. So. Yeah, like that's I'm sorry. I'm putting the link to that in the notes because it's important. So the Bop It is just this game. It's this toy that has a couple different things that you can do with it. One of them might be that you can like bop it, you could pull it, you could twist it, right? But now usually these are things that first of all take time. So I've set a timeout of 2 seconds for each one. Or for some of them, like pulling it is pretty fast, but twisting it and setting time and bopping it, these two things take time. Just because of the demo I did. And you have to do them in order, right? You have to first, like, depending on the thing is telling you, maybe you'll bop it, pull it, twist it, pull it, and then bop it, right? So I've written it as, first we bop it, and then we pass in a callback, right, that is pulling it. And then that pull it has a callback that is twisting. And that twisting has a callback that's pulling, bop, right? This is horrible, right? Look at this. This is so hard to read, right? It's so hard to work with. Now, I don't know how many of you are like, as your final project, you're like, I'm gonna make a bop it simulator, like an online multiplayer bop it simulator. Then you're gonna run into this, right? But even if you're not making a bop it simulator, if you're dealing with asynchronous stuff, you're going to deal with this weird pyramid. This weird pyramid of doom. Yeah, it's callback hell, right? It's just a nightmare. Pyramid of doom is one thing we call it. Callback hell is another thing we might call it. I just love this commercial. Callback hell. I'll put this link in the description. This is code that, at first glance, seems a little benign, right? You're like, I've seen this code, this kind of stuff before. But the more you really try, like, pulling this stuff apart, you're like, okay, bind this. Okay, I've got that. Bind this goes around a curly brace? Oh my god. Okay, so that, and then there's an else, and then the if, and this if lives inside of this callback. And what does GM even stand for? Like, I start pulling on my hair, my eyes go green. Actually, green's a normal color. My eyes go purple. Yeah, sure. I go like full on Hobson. Like, one person. So, things get hard for me to kind of figure out. And I want to keep my life as simple as possible as a developer. Like, there are things that I care about, like my family and eating well, right? And watching TV. In that list is not dealing with garbage code. Like, that's not one of the things that I care about. So, like, I'm just trying to make you understand that the things that we do to make code look nicer are to improve our quality of life, right? Our own quality of life, which, like, trust me, is really important. So instead of writing something like this, like, I might want to write something like, hey, can you first, let me copy this. Just scroll down a little bit. I'd like to, first of all, unindent all this stuff, right? I'd like to first unindent all this stuff. Now, this code is even more difficult to understand. But I'm saying that in the perfect world, I would like to be able to do, like, bop it, like, in an almost synchronous fashion. Well, bop is a verb. I bop. You bop.
Maybe like afterwards.
Oh, that's a good point. So you're way ahead of me. Okay, there we go. So I would like to be able to write something like this, right? But just by the nature of the bopping and the twisting, since these are asynchronous functions, right? Since these have a timeout, right? I'm not able to bop and twist and then expect a pull to happen afterwards, right? Just because of the asynchronous code, right? So this is not possible just yet, but I would like to be able to do something like, hey, bop it and then pull it, right? And then twist it, right? And maybe then pull it again and then pull it and then bop it, right? I would like to be able to do something like this. And lucky for us, there is a construct in JavaScript, right, in the newer versions of JavaScript that let us do this, right? And what this is called a promise, right? Now, I'm saying promise, and now I'm going to pull way back again, right? And I'm going to remotivate the idea just because I find that stuff kind of important. So one part here is to get rid of this doom pyramid, this callback hell, right? I want to fix this. Part of this is also like, assuming that the bopit function passed an elem to this callback, right? Assuming that it did. Or say we were connecting to a database or whatever. Like, say that something gets passed into this callback, and say that the pullet also passes something to its callback. What is the value of elem in here if I go elem? Right? Now, I know using VS Code, if I click on the name of any variable, it'll highlight every instance of that variable. Right? So here it's telling me, hey, if you're talking about elem, it refers specifically to this highlighted one, not this other one. But that's because VS Code is cool, right? But if I don't know that, right? Say this code is underneath just a bunch of trash, and I just have to keep scrolling, and I'm like, okay, I see the word elem in here. Is that this elem? Oh no, like I'm also shadowing that elem over here, right? I'm trying to show you this is confusing code, right? I don't want you to be comfortable with this, right? This is confusing, right? Because the deeper I go in, say each one of these required something being passed into the callback, right? I would keep having to come up with like more and more unique names just to not confuse myself, right? Or if I needed to use the values from outside in here, I need to make sure that I have 2 different names so I can access those things, right? And that's horrible. I mean, I have enough trouble coming up with examples. Like, you know, bop it, pull it, twist. Like, I had to go into like a meditative state to come up with this. I had to straight up go into the desert and whatever, like, bop it, right? Like I got it, right? This is gonna make sense. Coming up with variable names is horrible, but I don't want to do that, right? So I would like a way to fix that, right? So that's one more reason, and then the last one, which I think is actually pretty important for you to really get. So like really listen up for this one, is inversion of control. Okay, so when we use callback style programming, right? When we use callback style programming, we're giving up the execution of our callbacks to the third-party libraries, right? So we don't have any control over when the callback gets called, right? We can maybe look into the documentation and see, right? You know, we could dive into the actual code of that third-party function, but like how many times have you really gone into like the jQuery code to see how jQuery works on the inside? Or we used Mongo last week. Like, did you go into the Mongo.js libraries to see how Connect works? I didn't. I have better things to do, right? I would just like to accept that it runs when it needs to be run, right? But the thing is, we've inverted that control. I've handed the keys over to the third-party developers, right? So not only when the callbacks are being executed, right, but how often are the callbacks being executed, right? So if in my callback, right, I put in some really sensitive code, like maybe, as an example, charging a credit card, right? I don't know if I'm using a callback style thing, how many times is that charge a credit card code going to be run, right? I just have no idea, right? Because I'm just passing it in. I'm just going in, like pass it in, and I'm assuming that the function that takes the callback is only going to run it once, right? But if it runs it twice, then I've charged that credit card 2 times, right? Or say I'm printing some paper or whatever, right? Like, I don't know how many times and when is it going to be run, right? So I would like the peace of mind, right? I would like to take that control back and be able to say that, hey, I have this code that needs to be run after everything else is finished, and I only want it to run once, right? With promises, we'll be able to do that. We'll be able to write things like, where did I put it? Right, bop it. We'll be able to write things like bop it, then you pull it, right? I know that I'm pulling it after I've finished bopping it, right? You pull it, then you twist it, right? I'm not letting the people who made pull it make that choice for me, right? So inversion of control. And I really suggest doing some reading into inversion of control because it's a pretty cool concept. It's just kind of like a pattern for design, right? And you'll see it pop up in a couple different places. So bop it, then pull it, then twist it. And I would like to write this in JavaScript code. So lucky for me, that stuff already kind of exists. I have an example over here I'm going to scroll down. And, oh man, actually this is a bunch of code. So you know what I'm going to do is I'm actually just going to write it. No, close. Daft Punk 2.js. Okay. So is anyone here familiar with Daft Punk? Yeah, so Daft Punk, French electronic duo. They have a hit song, and it goes, work it harder, make it better, do it faster, and that makes us stronger, right? Now, the sequence of it is important because I need to work, and then, okay, the more I say it, the more I forget it. I need to work it harder, then I need to make it better, then I need to do it faster, and then that makes us stronger. For those who aren't familiar with the song, because there are people who aren't familiar, Calgary, I don't think you get audio, but I suggest maybe like Googling this real quick. There you go. So, all right. So there's an order to it, right? Like I have to work it harder, then I have to make it better, then I do it faster, and then that makes us stronger in the end, right? Thanks, Joel. Right. So I'm glad I found the short version of it because last time like we had to wait for the whole intro, and I'm like, no, but like it gets good. So I'll also put this in the notes. Yeah, I've done this before. So you have to work it harder, then we have to make it better, do it faster, that makes it stronger. So if I was to write that out as functions, oops. You know, work it harder. Okay. Oh my God. Okay, so make it better, do it faster, and then that makes us stronger. Now, each of these things takes time, right? It takes time for me to work harder, right? Like I can't just immediately work harder. I'm working harder now. Like there's an incremental kind of nature to it that's going to take some time, right? Now I'm working harder, right? And then making it better, again, not an immediate thing, right? You have to practice, and then things get better over time, right? Making it better also is going to take some time. Doing it faster, same story. And in the end, that makes us stronger, right? As a final kind of situation, like in the end, we become strong as a culmination of these three things. So what I can do is I can write this stuff as promises. So here's a bunch of code. I'm going to scroll through it slowly. This first one, I'm just going to put some lets in front of it, just because I feel uncomfortable. Since the last time I wrote this code, now I'm like, no, I want lets. So let work it promise, right, equals a new promise, right? We haven't seen the word promise before written out like this. We've seen error or whatever. Here's a new promise. And what a promise is going to do is it's going to take some resolution, right? It's going to take some resolution, and eventually it's going to run that resolution, right? It might make you a bit more comfortable if I wrote this word here as CB, and then I said CB over here, right? It takes in some callback, and then eventually it will run the callback. For me right now, I have that work it, right, will run the callback after 1,000 milliseconds. So after 1 millisecond. And not only does it run the callback, but it will be like passing in work it harder to that callback. Yeah, actually, I'm not entirely sure about this one. Let's see. Yeah. So anyways, I'll break this down a little bit more, but I wanted you to see the code in action first. Similar idea for the make it promise. I'm making a new promise that says eventually, I'm going to change this back to the word resolve, and I'll explain what that means in a second. In this new promise, we're going to set a timeout and eventually run resolve after 2 seconds. Okay? Same thing with do it. This is going to take 200 milliseconds instead of 2,000. Okay? and it's going to run resolve after 200 milliseconds, right? Now a promise is like an IOU, right? There's a little story that I want to take from the I've adapted from the book. Where'd you go? Here you go. So no, this is Kyle Simpson's book. Yeah, Don has a book on like project management and stuff, right? Yeah, I haven't read it, but I should. So here's a story. I go to a burger place and I order a burger, right? After paying, I have a receipt that's given to me from the cashier with my order number on it, right? This receipt is effectively an IOU. I don't have the burger yet. It's an IOU for the burger, right? After waiting around for a while, my order number is called, and then I can go and exchange my receipt and pick up my burger, right? So I got my receipt. They finish the burger. I go give them the receipt. They give me my burger. We're done. I go away and I eat my burger, right? But it is possible that my order number gets called, right? And I get told that actually the restaurant is out of stock of burger patties. They're really sorry. They refund my order, and I give them the receipt back, and it's fine, right? I just don't get my burger, but I move on with my life. These are two things that can happen, right? These are two possible scenarios, and I can handle both of them gracefully in real life. I have this IOU, right? And then when it's time, we figure out what's going to happen. But there's this asynchronous thing going on, the making of the burgers. Cool. So with promises, it's the exact same idea of receiving some IOU, right? With the promise that eventually it will turn into something, right? Or it'll fail, right? But either way, we know that we can handle that, right? So I have in here, a promise is a state machine. Do we know what a state machine is? No. Okay, so a state machine is, let's just pick this example here. Okay, so here's an example of a state machine. Something is locked. This is the starting point. I'm locked, right? I don't know exactly what I'm dealing with here, but if I put in a coin, I become unlocked. And as long as I'm unlocked, as long as I put in coins, I stay unlocked, right? But if I'm unlocked and I push, then that locks. And if I'm locked, and instead of putting a coin, I push, I stay locked, right? Now, I don't know what this example is about, but I want you to see that there's two different states, right? Being locked or being unlocked, right? And I can travel in between the different states via actions. Right? And depending on the state that I'm in, different actions do different things. Okay? So this is the idea of a state machine. I'm traveling in between these states, and the state is going to represent what is... Okay, wow. The state is going to represent what is my program currently like, maybe, right? A promise has the same kind of idea. A promise might start off as pending, right? A promise might start off as, okay, it's not done yet, right? We'll wait on this. So if I order my burger and I get my receipt, my burger is currently pending. It's not prepared yet. And then my burger or my promise might succeed. I might get the burger, or my promise might succeed, right? Or it might fail. Yes?
Was that what the set timeout is for? You could not long make the promise?
So my set timeout here, I've put this code in just to make this this is going to be this is the anonymous function passed into the promise. I've put set timeout in here just to make the code take some time, right? But this might have been like connect to database, right? Like just some asynchronous code. That's just the easiest way to make some asynchronous code in JavaScript is just to set a timeout, because this by default it's async, right? So all these set timeouts I put in there just as a hack to make my code take some time. Okay? And the thing is, my promise starts off as pending, and eventually I can either resolve my promise to a value, which means we succeed, here is your burger, I've resolved to a burger, or I can fail, right? I can fail and I can say, hey, we didn't succeed. Okay? So right now the code that I have, right? It only takes one parameter called resolve, and it's calling resolve, right? Like at some point in this code, inside a set timeout, it's going resolve like that, right? And passing in work, work it harder, right? But the idea is just resolve is something being passed down into the promise, right? And I can call it eventually. Okay, we'll touch on this a little bit more in a minute, but I want you to know that a promise can either resolve or reject or fail, right? And I can start doing things with these promises. Like I can actually start using them. Now I have a promise up here called a Daft Punk promise. Okay, so the different types of promises that I have are the Daft Punk promise, which is my begin, right? And I've written this one to take in two things, one being a resolve and one being a reject. And you'll notice that I'm only running resolve right now. Okay? This is a promise that immediately resolves to a thing, right? It immediately says, okay, we've succeeded, continue on, right? Continue. And it says, let's begin, right? And now I can start chaining these things together. So if I look at where I'm using it, I'm gonna copy over a bunch of code and I'm gonna trim it, so don't worry. Okay, so given the fact that I have this Daft Punk promise, right, I can then, right, so then, after a promise, I can go dot then, and I can pass in another thing to do. I can pass in a callback. So that's that idea that I had from the bop it, is I wanted to go bop it, then pull it, right? Here I'm going, start the Daft Punk promise, then start the work it promise. Now in here, I mean, I could have just done some synchronous code, but I decided, you know what, I'll start an entirely new promise. Like you finished one promise, let's make a second promise, right? And then after that second promise is done, then do this other thing. And then I'm just telling you right now that this here is like it creates another promise. So after that promise, then I can do more things. And that then creates another promise. So I can keep chaining this stuff as long as I want. I can chain a promise to another promise, to another promise, to another promise, right? Okay, so I know conceptually maybe that feels weird. I don't expect you to understand the code just yet, right? Just want you to know high level, this is what I'm trying to do, right? Is once a promise is resolved, then I run the next promise. And then when that promise is resolved, then I run the next promise, right? Now, did you have a question?
I do have a question.
Yeah.
So in our construction of work at promise, if work at promise had the ability to err, we would make sure that we pass the first parameter of the return value as error, and that way people could always do, the first parameter is error and then handle that error appropriately.
So actually, the question for Calgary was, if the work at promise had the ability to fail or to have an error, right? Would we pass error as the thing to the next one? The answer is no, right? So actually, with promises, we're no longer bound to error first callback style, right? What we have is, like I said, a promise can succeed or fail, right? So let me look up a state machine for promise state machine. I've drawn this before, but I'm just not good at drawing it. A promise can either be pending, and it'll continue to be pending until it either resolves or it rejects, right? It passes or fails, right? And then we move on with our life, right? So right now I'm just doing dot thens, but I'll show you something to handle a failure soon, right? But the dot then is going to take the success of the next thing, right? So right now, the code that I've written is always resolving. Then I wouldn't know. And in fact, I mean, I could go reject here, right? And I'm taking reject from this, right? So I could do that. I'm just not currently running it. I'll do that example in a second where I'm rejecting things. But in short, no, we don't have to do error first callbacks anymore because we have access to this resolve reject style of doing things. Now, if I'm looking at the code over here, okay, Daft Punk promise, then run the work it promise. And if I look at the work it promise, it resolves with a value, work it harder. Right? It resolves with a value that's work it harder. If you wanted to imagine this not written in the set timeout, it would be written as resolve to work it harder. Right? So work it harder becomes the value that comes out. Right? If I'm going back to my burger example, the resolved value is the final burger that comes back. Right? I've been given the receipt as a promise that this will be a burger. Right? So I can start imagining as if I have a burger now and handling that. And the reason I say that is because if I look down here, the way I've written my then after my work it takes in a value. It takes in a value, and I can say I can start doing things with that value. Okay? And that value might be the thing that gets outputted by this. Right? And that is whatever I resolve with. So the string work it harder. Right? Work it harder, and then I say, hey, now return the make it promise. Right? So from here now I'm returning like the entire make it promise, and that's going to be run, right? And then we'll do the do it promise, and then we'll do the makes this promise, and then we'll console log the final value that comes through if I follow through in the string of things. Right? And if I was to, let me just make sure I'm not missing any boilerplate code down here. No, I'm not missing anything. If I was to run this now, I've called this Daft Punk 2.js. Takes a second, says, let's begin, work it harder, make it better, do it faster, and then eventually it makes us stronger, right? No, it's really teeny tiny. Right? And what I really want to draw your attention to is the fact that it takes time. Yeah, because of the timeout functions. And some of them take more time than others because my timeouts are not equal. One of them takes 1 second, one of them takes 2 seconds, and another one only takes 200 milliseconds, which is near instant, right? So we'll see like do it pops up actually really fast, right? Let's begin, work it harder, and then do it comes up almost as fast as make it better comes up, okay? Just because of my timeouts. Well, I mean, like if I hadn't written it as dot thens, yeah. If I hadn't written it as dot thens, exactly. So in fact, I mean, if we really want to see that, like I could, okay, I'd have to rewrite it because I've written them as promises now. But yeah, sure. If you want to try that out, then you'll see that it'll come out immediately, just like we kind of did with this over here.
Well, how would you write it so that it happens like that? Can't you just call the function call?
That's a good question. Like, how do we make them all run at the same time instead of one by one?
Yeah.
Because sometimes there's just a bunch of asynchronous stuff that we want to make sure all finishes together, right? Yeah. So it's. Did you look into my notes? That's a good question.
No. Doesn't JavaScript automatically like call?
Yeah. But the structure of this thing is you'll notice that this is a function. This is a thing that has a dot then inside of it. That has a dot then.
If we weren't writing it.
Oh, sure. If we weren't writing it this way, then. Mm-hmm. But right now we've listed this out as like I don't know what's going on inside of dot then, right? This is some construct that sets up an asynchronous kind of step-by-step sequence for me. Like notice that this is all everything I've highlighted is one expression. Okay? If I was to throw a semicolon in here, it would be right at the end. Right? That's what I mean. Like this is all technically one line of code. Right? We just put new lines into it so it doesn't get unwieldy. Otherwise it would be like this. Right? And that's just kind of freaky. Right, so with that in mind, if I was to hop over to Daft Punk over here, so I'm running each one of these in a row, right? And then I actually didn't show the makes us promise. Somebody had a question about failing. If I look at the makes us promise that I pasted in, my set timeout's actually a little bit more complicated than the other ones. I'm setting a timeout for 4 seconds, and then when it makes us stronger, I've got a ternary, like I have some logic in here, right? And I'm just checking the value of true, right? So if it's true, then resolve with makes us stronger. If it's false, right, then it'll reject with the string oh no, right? And you know, if I do this right now, actually off the top of my head, I can't remember. right? Okay, so if I reject and I'm not handling that rejection, this will throw an error and it'll say, hey, unhandled promise rejection warning, right? You threw some kind of rejection, right? But you didn't handle it, right? So what we have to do is catch those issues. We have to catch this stuff. I'm just gonna see if there you go. So I can throw a catch. I can throw a catch for an error. And I can console log whatever that error is, right? So right now I know that makes us is throwing me an error because false is going to throw a reject, right? So in my promise like situation here, I can go dot catch, right? Very similar to our try catch situation. And now when we run into the error in 4 seconds, I can just console log the error and just handle that gracefully. See, catch, console log, right? Yeah.
Does the catch skip the rest of the thens? Like if it errors in one of the other promises that are above that?
Sure. I mean, let's see.
Try it.
So I'll throw the error when I get to. Okay, let me just make sure I've got this dude written properly. Okay, I'll throw the rejection. So this is do it faster. So I'll throw the rejection when we get to the do it promise, and I'll see if we ever we do it and then it makes us, right? So we'll see if makes us ever even runs. No, yeah. Thanks. Yeah, you're right. I missed the this part here. I'm trying to run reject without actually passing in reject as one of the things. So I need to have reject in here. Good catch. I need to have reject in here to be able to actually call reject. So now run this. Let's begin. And now, yeah. So I guess maybe I'd need to catch. Did I say that was on the do it? Why am I doing that? Oh, you know what? I think it's because I still have. No, that doesn't make any sense. Give me a sec. This is what happens when Nima goes off the rails. He doesn't know what his code's doing anymore. Okay, well, let's see. This says. What does this even say? Unhandled product. Because I don't have a line 18,000. Asynchronously. Let me see. I'm just trying to see if I'm rejecting somewhere that I don't resolve. False. Reject. Do promise catch. I'm on. What's that? No. Yeah. Okay. How about for this situation, this question? Sure. I'll come back to this, and I'll do it in the notes, and I'll send out like a Slack message, just because I don't want to keep you past a certain period of time. But that is a good question, and I hadn't thought of that. So let me just undo a bunch of garbage. Just going that? Oh, so a promise is a new object that we're making, right? By going like that?
Equals, just without the new.
Oh, okay. When we create new objects in JavaScript, we need the new keyword to say that we're creating a new instance of a thing. Actually, don't think it would work without the new. Yeah. Might be part of the promise notation. Let me note that down as well. Like, why do we need the new keyword specifically? I'm gonna put that in the notes. So why do we need the new keyword when making a promise? And then also the other question was the catch situation. I honestly think I just put in I just wrote the code. I mean, I obviously wrote the code wrong somewhere, but like catch should catch everything. More into that. Okay, so I'll dive into this in the notes then and make sure that your questions are answered. What I did want to look at before I let you go though was you had a question about having like a bunch of promises that don't necessarily, or a bunch of asynchronous stuff that doesn't necessarily need to run in order, but I just want to make sure that all that stuff is done before I can move on, right? Like if I'm getting ready to go out, like in the morning, I don't really care if I have breakfast, put on my makeup, like, put on clothes or whatever, and then, feed the dog. Like, I don't need that to be in order. I just need to make sure that that stuff is all done before I leave the house, right? So what we could do is use a thing called promise.all, right? So we would promise, so we're making a new promise situation .all, right? This is going to take in a array of different promises, right? Now, this code looks weird. I'll dive into it in a second, but I just want you to know that we can go promise.all, and in here pass in a bunch of promises, right? And these will all run, all of them, not necessarily in order, right? And then when all of them are finished, then we can do something, right? So this is where we don't care about the order. I encourage you to look into promise.all. So for the example that I have here, is I have, imagine this says promise 2. I have two new promises. One console logs out the word, or not console, one resolves to the value 1, and another one resolves to the value 2, right? 1 and 2. And I'm saying, hey, run both of the promises, right? And then when you're done, console log whatever value gets passed into the end here, right? And don't worry about this comment on line 60 just yet. If I was to, I'm going to comment out all of the Daft Punk stuff, so I'm not polluting the console. But if I was to run Daft Punk, that now, oh, okay, it's still actually, did I have that stuff in here somewhere? Oh, I did, whoops. That's what it is, okay. I get, no, am I still running? Why is Let's Begin going? Yeah, I'm passing the thing in somewhere silly. Okay, yeah, we'll console log everything, just the whole damn thing. Hey, okay, all right. So I've got this promise that resolves to the value 1. I've got this other promise that resolves to the value 2. They take different amounts of time, right? One takes half a second, one takes 1/10 of a second, and I say, run all the promises and then get all of the values, right? I might rewrite this as values just to make it clear that I'm talking about a plural, right? And then what I get in my values is an array of everything that these things resolve to, right? In my case, they both resolve to 1 and 2, right? Sometimes I might say, hey, I don't care about all of them, just the first one. Like, okay, so my friend Chad, one day he's like, hey, Nima, check this out. And we were in class, and he shows me his phone, and he had Tinder open. And he was talking to like 8 different girls. And he sent them all the same message, right? And he's like, and I'll just, I'll go out with the first one that replies, right? It's like a race. Yeah, he sounds like a real Chad. He's a very, he actually got into like a relationship with a really nice girl, not off of Tinder, and it changed him a lot. He's really sweet. But so there's it's still Chad. So So all is like all of them are going to respond, or some of them might decline or whatever, but I'll talk to all of them, right? Race is just the very first one, right? The very first one. So right now, the very first one that replies is promise 2, right? Promise 2. So if I go race, and they race for it, then I just get 2 back, and it drops the other promise. It's like, I don't even care, like just drop it, right? Unmatch, whatever, right? Yeah, the first one that makes it. And I could have 85 different promises here, all running to get to be the first one, and only the first one gets used, and everything else gets dropped, right?
Real life situation
Sure. Maybe I'm trying to like connect to one of many different connections that all are really equal to me, right? They're all fine, right? But I just want the fastest one. The fastest one is going to be the one that I connect to first, so I might as well then just drop all the other connections, right? That's yeah, sure, like a network connection, right? Like I'm trying to connect to maybe it's like an MMO game, right? And there's many different servers. I'll connect to the first one that I can, right? Instead of trying one and then trying the other and then trying another and then figuring out which one's the fastest, just try to connect to all of them, and then the first one that connects will drop everything else, right? That is a real life scenario where you might do something like that, right? Good question. Yeah. So, and then for the all, that might be, say there's a process on your back end that has to do a lot of different things. Like when a user signs up, send an email, print out a t-shirt for them, add a message to the message board that a new user has signed up and whatever, run some analytics, all these things, right? I might put them all as promises and make sure that they all run before I continue, right? These are all things that I don't need to wait for one after the other, right? I can just do them all at once and then move on once they're all done, right? That would be a situation where I might go promise dot all. Yeah, super, super useful. Now, you might not be creating a ton of promises, right? So I've created these promises, promise 1 and promise 2, my Daft Punk promises. A lot of the time you're not creating your own promises, you're dealing with promises that other people are making to you, right? So when we were doing Mongo stuff, where's Mongo? Mongo here. If we look at the, okay, I might get this wrong. Let's see, promise. No, okay. Trying to remember a thing that uses promises. Connects is promises. There we go. So connects, the SQL builder gives you promises and callbacks as part of the thing that you can do, right? So we can do things through the promise interface, right? So they're like, oh, here, you're free to use the promise interface, and now we know how to do the promise stuff, right? So say there were a bunch of different queries that we wanted to do, one after the other, dot then, dot then, dot then, dot then, right? Say we wanted to run a bunch of things all at the same time and then just aggregate that information, go promise.all and then pass all the queries in, right? So it's more about handling promises that other people have made for you than creating your own promises at the moment, right? And then again, anything you can do with promises, you can do with callbacks as well, right? So Connects offers a as callback way of doing things, right? So yeah, and then really that's about it for what I have in my notes. Errors and promises. If we want to really quickly go back here and go up to my goals, just to make sure that we've addressed everything, we addressed the fact that try, catch, and finally are the ways to handle synchronous errors in our code, right? If we have errors in async code, then we'll be using callbacks, right? And then we can write promises to get away from the pyramid of doom and to take back that control, right? Instead of having the control inverted, we take back that control, right? Yeah. Are there any questions? No? I'm just going to check on Calgary 1 sec before I let you all go. So 10, 9, 8. Nah. Okay. Calgary doesn't look like they have any questions. So with that, thanks for sitting through this. Have a great rest of the day, and I'll be around for the rest of the day to help you out with this stuff. Nope. Thanks, everyone.